Alright, welcome back. We've got episode 29 now. We're going to revisit this concept of parallel operations using applicatives, and especially with the future context from ramda-fantasy or wherever you choose to give it. Obviously, if you've watched much of this, you know that I'm a pretty big fan of Ramda. So once again, we're in Run Kit here, and I got to be honest, I'm liking it quite a bit. Episode 29, I'm Reed Evans. Alright, so where we had it last time, we had our home page, and to render a home page, we said that we needed a user and an array of posts. And from that, then we could generate HTML. In this case, I'm actually legit using React now. I didn't realize that it was already built in, so we're legit using React. So this is good. This is some JSX. But really, your view engine of choice here, the implementation for that doesn't matter. The point being the function signature here. So our function signature knows nothing about futures. We're able to lift that home page to where it knows now that given an applicative of a user, an applicative of an array of posts, we can return an applicative of HTML. So obviously that's what the lift does. And then we have our, where we had it before was we said that user F would just return something. Now user F is dependent upon you passing in an ID. So the thought being here is, well, before just everything was parallel. But what if we have some things that are sequential and some things that are parallel? Well, as it turns out, we've already seen abstractions, if you've watched many of these videos, that will allow us to do that. And the abstraction that we want for sequential processing is actually a monad. And as it turns out, future, because it's an applicative, it also implements monad. So what we can do is we can say we have this get current user future, and let's say that it's just it's the first one we call. So basically it's something we call, and I don't know, maybe the implementation looks something like check their cookie or some header value to return what the current ID is, and then you can follow that up by issuing something to get like the full user payload here. So that's kind of the idea that we're going for here with this current user future and then the user future. But since this user future here returns a user and the current user only returns a user ID and the home page wants to know about a user, we need to chain those things together. We can't just parallelize all the things, because to call this we have to have this ID. So what we could do is we can say current user F, which is a future, it's a thing, it happens to be a monad, so we can call chain on it. And we can take the result of this current user F, this X here will actually be this user ID object, which is this guy here. That's what that X is. And so then we can call user F right here, passing the ID, which comes from the X ID from here, in as the ID parameter that will actually then return us a future of this. And if you've seen any of these other videos, the reason we had to use chain here is because of the shape of this function. This function takes an int, which obviously is not a value in a context, and returns a value in this future context. And because it does that, we want to use chain rather than map or apply or whatever else. So the neat thing here is now we have this getUserF function, which is created by simply chaining together or kind of composing really this current user F and user F. And what we're able to do now is to use that same lifted function here, which takes the applicative of a user and applicative of an array of posts and returns an applicative of HTML. We're able to use the exact same lifted function that we used back in our previous episode, episode 28, and call lifted. Instead of passing getUser, we call getUserF now, because we want to use the one that has sequential processing to build up the future. We can still get away with just the singular lifted function we call fork. If we run this, the value that we get down here looks a little different because this is actually the full React guy here. But if we look at what the children are here for this div that we've created, you see that in fact we have an user ID with 1, handle is Reed and Evans, and we get our different posts that we have here. So kind of a neat way of if you've tried to do anything like this with promises, it gets really nasty really quick. But in this case, we're able to use the exact same homepage function. This didn't have to change at all. Really, I don't think any of this got complex. We just had to make sure that we were chaining together our current user F and then our user F, so that we had the ID to call user F on for sequential processing here. But other than that, that didn't get any more difficult. And this absolutely hasn't had to change because we still just have the two things. So basically, if you create a function that contains everything you need, if some of those come from futures or whatever, you can just lift the whole thing, and this never has to change. This is still a very, very pure function. This is a pure function. In fact, all of these are pure functions until you get down to the application boundary here, where we actually call fork and actually go ahead and issue the web request. So there you have it, parallel operations with applicatives 2. I think next time we're going to show a little bit of traversable, because this obviously we're still tied to 2 arguments here, but what if we had an undetermined number of arguments here and we wanted to let the list or the array of applicatives that we passed in determine what we need to have here? I think that's what we'll look at next time, and for that we'll need the traversable type class, which, as it turns out, array implements. So there's a little bit of a teaser for next time. So we'll see what we get there. Thanks always. I'm Reed Evans. This has been episode 29.